You never should come in here not knowing that something's going on. So let's talk about what we're doing today. We know the date, right? It's the 8th. We're doing Move the Monster. This is transformations. This is not the most enticing lesson on planet Earth, okay? But I have to do it 4 times and you have to do it once. So I'm going to win on who has it worse. This is something, though, it's foundational. Transformations are going to be in every single unit we do from here on out. So it's redundant. It's a little bit it's a little slow, but it walks you through how each individual transformation works, and then we'll try to put it all together at the end. There is not Delta Math practice with this, so I haven't even looked at Delta Math. To be honest, I'm kind of scared to look at it. You should be at 100%, though. You should be able to be there because you've learned everything that's covered on Delta Math. I have a separate sheet with a couple problems like this to practice on, so that'll be your homework, is to do the sheet and then do the Delta Math. Next time I see you over a weekend, we're not going to forget everything over the weekend. You have a check for understanding. Will probably be towards the beginning-ish of class, and it's going to cover what we did last time, domain and range, increase, decrease, positive, negative, and then transformations as well. After today, you know everything in this unit. It's review day, test day next week. Test is 2 grades. I put this in on the calendar so you know when the retest window is. This is for Unit 1 and Unit 2. You can't be at one of those times. You got to let me know because I got to get retests done. 22nd is a big deadline. Eligibility check on the 22nd, drop date on the 22nd. So we got to have our stuff together by then. Does everyone know what next week is going to look like? If you forget, where can you go? Canvas. Okay, it's there. I take my time to update it, so use it. Okay, so I'm not going to talk through all of this because, again, my head is pounding, and also you don't need to listen to me talk the whole time. So I'm going to kind of let you work through this, but we're going to talk big picture here. It's a lot of pages. We're going to have a big summary at the end. Hopefully some of this will look familiar because truly you should have done some transformations in algebra and geometry. But probably not near as intensive as you're going to do them in Algebra 2. The good news about this, once you learn these rules, the rules stay all year long. So literally every single unit, we will have a transformations day. And there's 10 units. So these rules, they're not changing. They're the same. The graphs are going to change. For this first unit, we're going to be giving you just some kind of made-up graphs that we decided, nothing special. So here is so we call it a monster. It's supposed to be cute, but I'm not in the mood for it. Here's our monster, okay? And so they wrote down the original, nice, pretty points, and then how I want y'all to do transformations, and how I'm going to assess you on transformations is creating tables. So we need those points to start with, and then we're going to perform all of our transformations on those points individually. So here's a couple things to remember before we get going. What is the original domain and range of our little monster?
-3 and 0.
-3 is our, let's do interval notation first. How do you write interval notation? Because I'm going to be picky on the test. Square bracket, -3. What's the endpoint? +3 with a closed circle, so put a square bracket. How do you write that with an inequality? Okay, you need to be able to do both of those notations with something like this by next class. Okay, this is domain and range. All right, what's the range in interval notation? Yeah, I think that's just because they drew on it. I don't know why they drew on that, but it's at 1. And then in an inequality, very good. Okay, you can pick. You're gonna have to do domain and range on every single graph you do. Honestly, interval is probably easier, but I would just don't sleep on inequality because it's definitely going to be on your test too. Okay, so a couple notes to remember. F of x is the same thing as y. So if you see a function and they call it f of x, or we call this one h of x, whatever, The number inside the parentheses represents the x value. So it says like, if they're wanting to do like f of 2 or f of x plus 2, they're talking about x's like that. Outside numbers affect the y. I'm going to talk a lot in transformations about outside versus inside. And let me write you an example right here. Here's an example. What did they use? Did they use g of x? Okay. So we'll write this down so you can just kind of see what I'm saying. -2 h parentheses 4 parentheses x minus 1 minus 7. Let's write that down. Okay? That is jam-packed with transformations in here. But I want to show you what I mean by like outside of the function versus inside of the function. So outside numbers, those are going to be transformations on your y's. Those are going to be vertical transformations. So which two numbers are outside, two numbers are outside in what I drew? -2 and -7. Okay, how do you know that? They're not inside the whatever function we're talking about. So those would be affecting my y values. Inside numbers, what are the inside numbers here? 4 and -1. Inside numbers are going to affect your x values, but inside is always the opposite operation of what you would think. Inside is opposite, okay? And you'll kind of see what I mean there. So through the next couple pages, it's a lot of graphs. This has 1, 2, 3, 4, 5 transformations in the example that I just wrote. We will get to where we can handle 5 transformations at a time. Right now, we're going to go through basically one at a time so you can see how each one of these transformations, what it does to your points, what it does to your graph, what it does to your domain and range before we start throwing them all together, okay? So it's just kind of like baby steps. Again, it's a little redundant, but it's okay. Here's word banks for things that you're going to be looking at, okay? Vertical shift up, vertical shift down. Those are translations, okay? And vertical is up and down. You can shift horizontally, left and right. That's changing your x values. Vertical reflection and horizontal reflection. Vertical reflection means you're flipping your graph like this way, okay? What axis is that reflecting over? One of our teachers always says vertical and horizontal reflection. I always say which axis, but I know them both, but I'm going to write them both down. So vertically reflecting means you flip over the x. Horizontally reflecting means you flip over the y axis. Okay, so we do go over both types of reflections, and depending on what type of functions, it can make your graph change visibly, but also like that's something that people get tripped up on is which one is over the x and which one's over the y. What about vertical stretch and compression? What would that do to your graph? But yes, it's dilation. But again, we're doing vertical and horizontal. So vertical stretch is like taking your graph, stretching it vertically, compressing it vertically. So you can kind of think about what happens. If I took that graph and I stretched it out, what's going to happen to your graph? It's going to get skinnier, thinner. If you stretch it, if vertically, it's going to get thinner. If you compress it vertically, it's going to get wider. Okay, that one makes, I think, pretty good sense, especially if you kind of do what I'm doing with my hands and like actually do it. Horizontally, okay? Remember, horizontal, anything that happens to the x is opposite, so kind of keep that in mind moving forward. If you stretch it out horizontally, is it getting thinner or wider? Look at what I'm doing. Wider. It's getting wider, okay? So this one, and just think about the picture. If you compress it horizontally, horizontal always makes me think, what's that, that instrument? The accordion, right? You know how you like have that? That's what that makes me think of. So this would make it thinner, okay? So those are just like some helpful like hints as you use these descriptors. I do want you to say like it's vertically stretched. It's vertically compressed. I need to know the direction and like what exactly is happening to it, but this is just kind of how you see it, okay? So flip over. Let me just kind of get you started, and then I'm going to let you kind of work on these graphs with your tables, and then hopefully we'll have enough time to summarize everything. Again, there's a lot, but it's only doing one thing at a time just to try to get a really good understanding of how it's working. So I want you to approach each problem, and I want you to look at how they wrote this, okay? First thing, g of x, that's the new graph, it's equal to h of x. What did we name h of x? Or what did we name our monster? H of x. So this is what we're talking about. We're talking about this guy. So the way that they wrote that is they said, okay, you're going to take the old guy, the original guy, and you're going to add 2. Remember the inside-outside game. Where is this plus 2 happening, inside or outside?
Outside.
Outside. So look right here what I did for you. I set up your table. I am going to require that you do tables every single transformation that we do. And I also want you to put at the table what you're doing. You have no changes on your x. Your x values will stay the exact same as the original. However, your y values, you're going to apply that transformation. You're going to add 2 to each y value. So you need to be making me a bunch of new points, throw them on the graph, connect them, and answer these questions. Okay? So some of the ones actually write the table for you. Some of them you will have to go in on number 2 and again use your context clues and see if you can figure out what the rule is going to be. Okay? And it's going to walk you through one at a time. There's almost one that's filled out on every single page. And there are 12 graphs, so this is going to take some time. Okay, ready, set. Just for those of you that are catching up, okay, because y'all are kind of starting to ask me the same question. I just worked the first problem for you. Again, this is what I want to see. I want to see your tables. You don't have to circle, but I just circle that. The only thing that changed was my y's. As far as the descriptions, use the word bank. This graph went up too. Hear me out. Give me your eyes. Give me your eyes. Give me your eyes. I don't, with up, down, left, and right, for me, it is sufficient to say it went up this many, it went right this many, yada, yada. I don't need you to tell me that up and down are vertical and right and left are horizontal. I'm going to make the assumption that we can all get that. Okay. I do want you, when you get to the dilations, the stretches and compressions, those I do need to know which one, and it matters what value it's affecting, the x or the y. So really pay attention to what I said right here about outside affects y's, and outside is just normal math. Inside is opposite. So what's happening is a lot of you guys are getting to problem 3, and you're recognizing that this plus 2, where is the plus 2? Inside with the x. So inside is always opposite. I need you to, every time you see that, think of that. So in the table, which is already filled out for you, what did they do to the x's? They subtracted them, okay? Best explanation for what I can think of instead of just saying because is if you were to take think back to Algebra 1 for a second. I hope you're listening to me if you're curious. If you had a factor of x plus 2, in Algebra 1, how we would solve that is we take those factors and set them equal to 0. I kind of like to bring it back to a factor because when it's in the parentheses, it kind of looks like 1. It's not, because it's saying h of, but it kind of looks like that. And then to get x by itself, you would have to undo that operation by doing the inverse operations, which is doing subtraction. So that's why even though it's written in the parentheses as a plus, it's really moving in the negative direction, which means you're subtracting your x's. And that's why the inside kind of works opposite, is because you would have to take that out of the factor and then work from there, okay? It is what it is. You kind of got to trust me. Inside opposite is really going to help you, and then you'll see how that direction works. As far as domain and range, I would advise you to just alternate maybe between interval and inequality so you can practice both. You do you, okay? So I'm going to kind of try to work these graphs, and then I'll have a completed answer key on Canvas, but y'all are already working faster than me, so we might just have to reconvene in a minute. Okay, little checkpoint because some of you guys are getting to 6, 7, and 8. I'm going to freeze the screen up here for 6 and 7 just so that we can kind of follow where the negative goes. Again, with the negatives, negative reflections, all those are going to do, or negative transformations are just your reflections, okay? So you got to figure out which one makes you vertically reflect, which one makes you horizontally reflect. As far as going in the table, if there's a negative, you just negate the x or the y depending on where it is. Look at 7 real quick. reflections are the only time that the inside opposite rule does not really count. Because like on number 7, that negative is inside, correct? I can't just like ignore it. I do actually have to do the reflection, multiply my x's by negative. So that's like the one time inside opposite is not the same. Skip number 8, because we need to talk about 8. We're not quite ready for that. But if you're on this page, I think that's kind of where most people are. If you're not, try to catch up. I'm going to freeze the screen right here so that way if you do get to this page. But the transformation on number 3 was to the left 2. Okay? Going to the left and right, changed up your domain. Your graph shifted to the left. Number 4, your transformation was to the right. Okay? There's your domain and range. Do you see how I highlighted my little transformation rule up here? That's really important to me. Like when I'm grading, that's always something I'm going to look at. And I need that there because otherwise I need to know how you got these numbers. If you don't give me a rule, I don't know where those numbers came from, and I cannot award you partial credit for any of that. Okay? Number 5, kind of threw 2 transformations on it. Number 5, you had an inside transformation on your x. Inside's opposite. So your x's were to add 1. You had a 3 on the outside. Outside's the same. Y plus 3. What that did to your graph is right 1 and up 3. Okay? We are going to get to where we're doing like minimum of 3 transformations at a time. So this little activity was for you to really see how like 1 at a time affected it. Number 6. Okay, I want to make sure you know both these words. Sorry, this is sloppy. If you can't read it, let me know. Number 6, you had a negative. You guys, negative signs. Negatives, not minuses. Negative signs. They will either be at the very front outside, which means you're going to negate your y's, or they will be at the very front inside, which means you negate your x's. Negatives are reflections. That's all they do. Is there a reflection? There is no factor that it's reflecting, but you have to tell me whether it's vertical or horizontal. I don't care if you say vertical reflection or reflect over the x-axis, but I need you to know both. Do you hear what I am saying? I need you to recognize that vertically reflecting is reflecting over the x. We're going to get into some problems, maybe not today, but next class, where I ask you to write based off of descriptions, and if I give you this description, you need to know what that means. Here's how I always help people remember that. If you have a point and you want to reflect it vertically, okay? Flip it over. What axis did you flip over? The x. Like, just go to a picture, okay? If you changed the y value, you flipped it over the x-axis. And then vice versa. If you changed the x value of your point, then you flipped it over the y, okay? That's a horizontal reflection, also known as reflecting over the y-axis. We skipped number 8. I'll probably work out number 8 and put it on the key, but I don't have time to talk about it today. Then we get into the dilations. 9 and 10, both of these numbers were outside, okay? Outside is normal. Outside affects your y's, so our y's were doubled, and then our y's were cut in half. If you look at your graph, you can see what happened to it. When our y's were doubled, what did we do to it? Stretched it. I need you to tell me it's vertical. I need you to tell me it's a stretch. And I need you to tell me it's by a factor of 2. When you had a 1/2, what happened to your graph? Yeah, you crunched it. Okay, you vertically compressed it like that. Okay, so I need you to tell me it's vertical. I need you to tell me it's compression. I need you to tell me it's by 1/2. And we'll talk about how we'll know based on what those numbers are in a minute when we sum all this up. 11 and 12, I think, are the trickiest ones, okay? Because you're putting those stretches and compressions on the inside. But what do we know about inside? Inside is always opposite. So if I have a 2 being multiplied by an x on the inside, on my table, I'm really dividing x by 2. Or I wrote it as 1/2 times x. I normally will write it as that multiplication. But you're multiplying by the reciprocal. The graph was really helpful here. You can see that you took your original guy, and when you multiplied those x's by 1/2, it did this. Okay, so that's a horizontal compression. The factor that it is compressing by is what you used in the table. Okay, the reciprocal of what it was in the problem. This is kind of hard to do. I have a way to help you remember which one it is. And then on the last one, you had h of 1/2 x. Again, it was inside. Inside's opposite, so that meant you doubled all of your x's. When you look at your graph, you horizontally stretched it apart. So you need to say horizontal, you need to say stretch, and the factor that it's a stretch by was by 2. Yes?
When you're graphing out, with that last little section on the graph, do you just write it as like a smooth curve?
Technically, it was a little roundabout, but I don't know. I'm not that picky about that. I care more about the points and, like, yeah. Okay, so you're going to have graphs on your practice that have a whole lot of things going on, but let's get a summary page going, and then if we don't get to writing today, that's not that hard. We'll do it later, okay? All right, we're about to write a lot here. There are, in general, okay, 4 types of transformations, 4 places they can be. So we talk about those as A, B, C, and D, okay? A, B, C, and D. This is just in general. This is going to be the same thing all year long. So learn it once, you got it all year, okay? A and D, are those inside or outside?
Outside.
These are your outside ones. Outside is always easier. And then B and C, these are your inside ones. Inside ones are always worse. Okay, so you need to know what's going on. It's happening inside of the function. There will be some sort of function on it, whether it be in general, like with an F parentheses, or when we do absolute value next and you actually have absolute value bars in there. You'll be able to really see inside and outside, okay? So the first thing is if with the reflections. Actually, let's do left, right, up, down, because that's a little bit easier. Left, right, up, and down has to do with C and D, okay? We put some other letters on there because that's how they write quadratics. I don't know why they have to have different letters, but if you want to scribble out H and K for now, then you can do that. We'll just talk about C and D for now. Okay? My favorite one is transformation D. Transformation D is on the outside, isn't it? Outside's easy. Okay, this is on our outside. So outside is normal. So if we're adding a number on the outside, then how does that change our graph? Up by whatever that number is. It's vertical. I'm okay. Y'all don't have to tell me that's vertical because we know it's up. So if it's plus the number, then it just shifts up. If it's minus a number at the end, then it's going to shift down. Okay, that's the easy one. That's at the very end of the equation. You just follow your sign. C, however, is on the inside. Inside's opposite. Inside's a little bit tricky. So if you're adding a C, you're not really moving in the positive direction. You're moving in the, which is to the left. And you will move left that many units. I guess I should put these in, whatever. If you have a minus C on the inside, you're not moving in the negative direction because inside's opposite. You're really moving in the positive, which is right. Okay? So those are a little bit easier. The transformations, again, they're things that are being added or subtracted. They'll be towards the end, but you have to classify, is it inside or is it outside? Okay? Let's talk about A. A is happening on the outside. So all of these guys over here are outsides. I'm going to kind of put those together. And outside is always going to affect which value? What is it? Affect or effect? Affect? Okay. Sorry. Math teacher here. But I'm saying it like changes. Why? I don't know. This is embarrassing. I'm going to go with this. Okay. So this whole chunk of page here, A's and D's are always going to, we're going to say affect because, I don't know, and don't tell your English teachers if that's wrong. But it affects your Y values, okay? All right. First thing, if that A value, what does this mean right here? How it's written? If ignore the absolute value bars for a second. What does that mean? A has to be what? Between what two numbers? Greater than 0 but less than 1. What are some examples of numbers greater than 0, less than 1? 0.5. What else? 0.4, 0.3, 0.75. Okay, so if it is between 0 and 1, then that means that's your graph. Here's the transformation. It's an A value, so it's going to be vertical. And it's like you have a fraction smaller than 1. That's going to be your vertical. What do you think? Fractions. What do those make you think you're doing? Compressing. This is a compression. Vertical compression by the factor of A. You don't change that. It should be a little baby fraction. That means it's a compression by that fraction. Okay? If your A value, and again, it says absolute value, that just means ignore the negative if there is a negative. Okay? The number A itself, if it's greater than 1, what do you think is going to happen to your Y's when you multiply them by a bigger number? That's your vertical stretch. This one just kind of makes sense to me if I stretch by A. So if I have a smaller fraction between 0 and 1, I'm squishing it. If I have a bigger number, then I'm stretching it. Okay? And it's vertical because it's outside. It's the very first thing in the problem.
What's the first one?
The first one is if the A value is less than 0, which all that transformation is if you have a negative A value. And I need y'all to think of those as two separate things. If there is a negative sign, the negative does the one thing. Then the number itself does the other thing. So that's why they put the absolute value in there, because you kind of have to think of that as two separate things that are going on. If your A value is negative, that means you're multiplying your Y's. If you negate your Y's, what axis are you flipping over? Your X. This is a reflection over the x-axis. How's the other way you can write that? Vertical reflection. I want you to know both. If you're writing in, I don't care which one you put. But I want you to know both because we give you those in words, and I need you to know both the words. Okay? The way I help people remember is that, in the alphabet, X comes first, right? Last I checked. So if the very first number is negative, that's got to be over the X. If the second number or the second place is negative, that's got to be over the Y. So it's kind of like the alphabet here. Okay? So those all of these would affect your Y values. All of these guys, B's and C's, they're the annoying ones. They're on the inside. They're going to affect your X values. Okay, these are a little weird. I want you to write it down. I've got a way to help you remember. We'll start with B being less than 0. That means your B value is negative, correct? Okay. That's going to be the opposite reflection. How's that going to reflect? Reflect over the Y axis, aka horizontal. We're just going to finish writing this. And then you're not going to be able to finish your homework, but that's okay. You should be able to do half of it. Horizontal reflection. If your B value, okay, is, let's do greater than 1 first. If your B value is greater than 1, I'm going to go back to our example. And our inside value was bigger than 1. Number 11. What did this actually do to our graph? Compression. Okay, so these are going to be the opposite. So write it down. I'll teach you the shortcut next time. This is going to be a horizontal compression by 1 over B. That's how you know it's a compression, because if you've got that whole number in there, what it's actually changing by is going to be the reciprocal. And so you're going to be writing a fraction, and that's what makes you think compression. If B is between 0 and 1, horizontal stretch by 1 over B. Okay? So we got that all written down. I know that's a lot. Let that marinate. Let me show you what your homework is going to look like, and we'll finish it up next time. We will not do the CFU right at the beginning. We'll do a little warm-up, probably do the CFU in the middle. You can do the front page, okay? You got a new graph. You got 2 transformations on it, okay? There's a lot in here, so you really got to think about what your table should look like. We'll talk about the writing next time. Apologies that took so long, but we'll get it. We got time.